Alright, hello everyone, and welcome to my flip video presentation on adding fractions with unlike denominators. Basically what we'll be talking about in this video is how do I add fractions with unlike denominators, and why is it important to know how to do it. If you are using Edpuzzle, words in red on the PowerPoint will mean that a question is coming up in the video, so you should be ready to receive a question from Edpuzzle and answer it in order to check your understanding of what's going on. If you're on YouTube, there's a link in the description to access the Edpuzzle video, so feel free to check that out if you're interested. Alright, let's dive right into adding fractions with unlike denominators. So first of all, one of the main points I want to emphasize to you in preparing for adding fractions with unlike denominators is that it is not the same as adding fractions with the same denominator. This is very important to remember because we're going to have a little bit of an extra step in order to solve problems that involve adding fractions with unlike denominators. So let's take a look back at a problem that you may recognize how to complete. 2/10 plus 3/10. Alright, so something that you might notice about this problem here is that the denominators are the same. And since the denominators are the same, we are able to add the numerators together. So here's a little bit of a visual to help you see what's going on taking place here. So you have 2/10 of a whole in the first value here, and then you have 3/10 of a whole in the second value here. So if you put together these two, you would end up getting 5/10. 5/10 would be this part of the whole, because 2 plus 3 is 5, but remember we don't add the denominators together. The denominators remain the same, because the denominators are just representing the whole that this contains. So we have 5/10, and if we were to visualize that, we could see that this would actually be 5/10 or a half of a whole. So we could actually simplify this number further to be 1/2. So that's a problem involving adding fractions with common like denominators, but let's get into what we're going to be learning about today. Adding fractions with unlike denominators. So remember, it's not the same thing. Take a look at this one. 3/5 plus 1/2. Okay, so a bit different. You can see that there's two different denominators here. They're not the same. So what do we have? How can we solve this? Are we able to solve this? The answer is yes, you can solve this. You definitely can solve this. But it can't actually be solved in the form that it is now. But we can solve it by taking an additional step. But the reason why we can't solve it right now is because these denominators are not the same, so they aren't representing the same whole. So this is representing half of a whole. This is representing 3/5 of a whole. And if we want to make an accurate description of how much of a whole or more than a whole it represents, we will have to have the same denominator in order to accurately identify that. So the next step actually that we must take is we have to find the common denominator between the fractions. But what is a common denominator? Well, a definition for common denominator is the shared multiple of denominators between fractions. Okay, so there's another term in there you may have to revisit. Multiple. What is a multiple again? Well, a multiple is a number that can be divided by another number without a remainder. So, for example, if I have the number 5 here, see 5 is a denominator, and we want to find the multiples of 5. There's one multiple, obviously 5. Then we have 10. Then we have 15. Then we have 20. I think you see where I'm going with this. I'm counting by 5s, ... These will be the multiples of 5 because 20 divided by 5 is 4, 15 divided by 5 is 3, 10 divided by 5 is 2, and there's no remainder. So that's what a multiple is. So the multiples of 5 would just basically be counting by 5s. So that's a multiple. But the next step to take for the math equation that we have up here is to find the least common multiple between the denominators. How do I find that? So we have the multiples of 5 listed here. and we have 2 as our second denominator. We want to find the least common multiple between the denominators. So to do that, I like to just list the multiples. 2, 4, 6. These are the multiples of 2 right here. 8, 10, 12, 14, ... Now, the least common multiple is the common multiple between these two values that is the lowest. So if you look at this, you can see that the least common multiple between 5 and 2 is 10. Because that's where you have 2 of the same number, and it's the lowest number that is common between the multiples of 5 and the multiples of 2. So that's how we do that. So let's take a look at this. Let's revisit this problem here. I want to kind of show you a visual of what we're doing when we find the common multiple also. So we have 5 and we have 2. So we have 5, 10. We know what the least common multiple is. 2, 4, 6, 8. Hopefully my writing is legible enough for all of you. 10, 12. So what am I doing when I'm finding the least common multiple? Basically, in order to make these common multiples the common denominator, I have to multiply the original number by the number that it would take to make this number the least common multiple value. So in order to do that, I would have to multiply this entire fraction by 2 over 2. Why do I have to multiply by 2 over 2? Because 2 over 2 equals 1. And when you multiply something by 1, that means that nothing is actually really changing. All we're doing is changing the way that we are comparing the ratio of 3 to 5. Here I'm going to erase everything on the slide here. So here we have the least common multiple of 10, and we multiplied this by 2 over 2. If we multiply this by 2 over 2, just like I showed you just there, basically what we're doing is we're taking this shape and we're splitting it into 10 pieces. So if I draw this line here, you can see that there's a set of 5 pieces. This is the 3/5 right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 pieces now, as you can see it. So now that we do that, we can count the pieces that we have in tenths. 1, 2, 3, 4, 5, 3/5. Now instead of 3/5, it's 1, 2, 3, 4, 5, 6 tenths. So I'm going to put this over here, 6 over 10. And now we have to do the same thing for 1/2, but in order to make 2 the number 10, what do I have to multiply it by? The answer is 5 over 5, right? 5 over 5 still equals 1, but now we're just making this ratio we're converting it from 1/2 into 1 times 5 is 5 tenths, so that we can compare these values together. And what we're doing when that happens is we're splitting this into tenths also. So 1, 2, 3, 4, 5. So there we go. That's basically what's taking place here. So now that we have this, we can calculate what the answer for this is. So we can count these shapes, or we can just do 6 plus 5. So 1, 2, 3, 4, 5, 6. 6 tenths plus 1, 2, 3, 4, 5. I drew too many lines. Let me fix that, because it's that I accidentally made twelfths on this thing here. That was my mistake. So now this is tenths. Let's redo that. 1, 2, 3, 4, 5, 6 tenths plus 1, 2, 3, 4, 5 tenths. So we have tenths here. 1, 2, 3, 4, 5. 6 plus 5 is 11 tenths. So that is how you find a common denominator and then use it to solve a problem. We're basically just adding an extra step, and we're going back to like denominators. So now that I've explained to you what adding fractions with unlike denominators is, I want to explain to you what it is not. So, adding fractions with unlike denominators is not adding both the numerators and the denominators. So basically, if I were to do 3 plus 1 equals 4, 5 plus 2 equals 7, that doesn't look right, does it? Because, in fact, 4/7 is smaller than 3/5. If 4/7 is smaller than 3/5, I don't think we have the correct value because we're adding these two numbers together, and it should become larger than the original 2. So this definitely cannot be right. It also is not adding the numerators and applying the largest denominator. So if I were to take 3 plus 1 is 4 and just apply the highest denominator, which is 5, that's not right either, because we're not considering the size of this fraction here, which is 1/2. It's not 1/5, it's 1/2. So there's a big difference between 1/2 and 1/5. So if we just apply this denominator, this is definitely a lot smaller than what this actually should make. And you can see the shapes there to prove that. That if the answer was 4/5, it would just be this area here. But we have another half to consider. So it's definitely not this either. Adding fractions with unlike denominator is finding the least common multiple between the two denominators of the fraction. And remember, this is very important. You must multiply the numerator by the same number of the denominator in a fraction. Why is that important? Well, if I were to just multiply this by 2, I would have 6/5, which isn't right, because 2 is not equal to 1, and we want the fraction to have the same value. So we have to multiply by 2/2 in order to get 6/10 for the least common multiple between the two. Same for this one. We can't just multiply it by 5. We've got to multiply it by 5/5 in order to find the least common multiple, which would be 5/10. So, multiply the numerator and the denominator by the same number. That's very important to remember, because that could lead you to make a number of different mistakes in your process of solving these questions. Alright, so let's try another problem. First of all, I want you to try and solve this problem on your own first. If you're using Edpuzzle, you will get a question pop up that will pause the video automatically, but feel free to pause the video and try and solve this problem on your own first. And you can also rewind the video if you struggle to remember how to solve the problem. Alright, so hopefully you were able to solve this problem. So what was the first step? Step 1, you probably had to find the common denominator between 4 and 3. How do we find the common denominator again? We have to list the multiples. So the multiples of 3 are 3, 6, 9, 12, 15. I'm just going to go up to 15. It's because I don't think we'll need to go any farther. Sometimes we may have to go a little farther than that. So for 4, you got to do 4, 8, 12, 16. And notice the common denominator there? The 12. The 12 is what's common. So basically 12 will end up being our common denominator for this problem. So the next step is we have to multiply the numerator and denominator of each fraction by the number needed to reach the least common multiple. So in order for 4 to reach 12, we would have to multiply by 3. So 3 over 3. Remember, we have to apply the number to the numerator and the denominator. So 3 times 1 is 3. And 3 times 4 is 12. So this 1/4 is the same thing as 3/12. It's just not simplified into 1/4. We're basically unsimplifying fractions in order to come about with a accurate solution. So plus, what's this? How do we get 12 from a third? We have to multiply by 4/4, right? So 1 times 4 is 4. 4 times 3 is 12. Now we are ready to finish the problem. add the numerators. Make sure you not to add the denominators because that would not give you the right answer. So 3 plus 4 is 7. And the common denominator is 12, so 12. And that's your answer. Yippee! I did it! Alright, so we've talked about how to add fractions with unlike denominators, and we went through a practice problem to help you understand what that means. But why is it important to know how to add fractions? Now there's a couple, it's important to know how to do this, and the best way I think I could show you why it is important is to give you a real world situation to help you understand. So we're going to do a mathematical situation and try and solve this situation. So Albert and Sam were selling chocolates, that should be an S, chocolates for a fundraiser. They each had one box of chocolate containing 12 pieces of chocolate. They split up across a few blocks of town and after 1 hour of sales came together for results. 2/3 of Albert's box of chocolates was sold. Sam sold 3/4 of the chocolate in his box. Each chocolate cost 75 cents. How much money did they make after 1 hour of sales? Now that's a lot to take in, and I'm going to ask you to try and solve this problem on your own first. I know it's a lot, but I think you can do it. If you have questions, make sure to refer back to other parts of the video hopefully you will find your answer. But try and solve this problem on your own, and then I will help you solve it at the end. Alright, you think you got it? Let's see. Alright, so Albert and Sam were selling chocolate for a fundraiser. They each had one box of chocolate containing 12 pieces of chocolate. I think that's an important thing to know, so I'm going to underline it. 12 pieces of chocolate. They split up across a few blocks of town, and after 1 hour of sales, came together for results. 2/3 of Albert's box, I think that's also important, of chocolates was sold. Sam sold 3/4 of the chocolate in his box. Each chocolate cost 75 cents. This, I feel like, will come more at the end. How much money did they make after 1 hour of sales? So there's a couple problems that we're going to have to solve here, and there's a couple of steps we're going to have to take. So the first thing we're probably going to have to start with is figuring out what 2/3 of Albert's box of chocolates means in terms of 12 pieces of chocolate, and 3/4 of the chocolate, what 3/4 of the chocolate represents. So this turns into an adding fractions with unlike denominators problem. We have 3/4 and 2/3, and luckily for us, we've seen 4 and 3 before, so we know what the multiples of 3 are. 3, 6, 9, 12, and then we have 4, 8, and 12. So we can see that pretty clearly, that the common denominator is 12, which is the number of chocolates that we had. So this problem has been quite simplified for us so that we have 12 pieces of chocolate. So basically what we do now is we have to make this denominator 12, and we do that by not changing the value of the fraction, by multiplying it by 1, or if we were to put that in a fraction, 3/3. So 3 times 3 is 9, and 3 times 4 is 12. So we can determine that Sam sold 9 of the 12 chocolates in his box. And then we can also determine that Albert, when we multiply this by 4/4, because we need to make this denominator 12, 4 times 2 is 8, 3 times 4 is 12. We can determine that Albert sold 8 of the 12 chocolates. So in total, 9 plus 8, we're adding the numerators now, not the denominators. 9 plus 8 is 17. 17/12. So they sold 17 of their chocolates. Chocolates. Alright, so now that we have 17 chocolates, we've got to remember that each chocolate costs 75 cents. So, to determine how many chocolates were purchased, or how much money that they earned after the sales that they did, we can multiply 75 cents by 17. And what is 75 cents times 17? 75 cents times 17 equals $12.75. So they made $12.75 after 1 hour of sales, which is not too bad. Congratulations! You have learned how to add fractions with unlike denominators. Please refer back to this video if you have additional questions, and if you are on Edpuzzle, a quiz is coming up momentarily that you can solve.